Okay, I'm going to take you through the derivative of the sine function. First and foremost, there is a little bit of a glare off the board. I'll try to clarify that as I go along. All right, so I'm going to define y to be sine of x. I'm just going to use y and x notation here. I could use f of x notation if I chose to, so I could replace y with f of x and then y prime with f prime of x. Same thing. So if y equals sine of x, we're going to use the limit as x approaches, as h approaches 0 of f of x plus h minus f of x over h for the definition of the first derivative. So I have y prime equals the limit as h approaches 0, sine of x plus h minus sine of x over h. So this is the addition formula for the sine ratio, and that's from Trig. It's also in the back flap of your book. So that's defined to be the sine ratio of the first angle, which is x, times the cosine ratio of the second angle, which is h, plus the cosine ratio of the first angle times the sine ratio of the second angle, which is h, minus f of x, which is sine of x, all over h. I'm going to do some algebra here, and I'm going to split this up over two separate fractions. I'm going to take a look at these two, put these together, and then I'm going to write this one separately. So this is sine of x times cosine of h minus sine of x, which I did here, and I did a little algebra first and foremost. I'll explain that in just a moment, plus cosine of x times sine of h all over h separately. And I split it up with a plus and then h in the denominator. Now these two share sine of x in common, so I factored that out. So I have sine of x times cosine of h minus 1 all over h. And again, h is going to 0, so as h goes to 0, this quantity right here also goes to 0. That was one of our limit properties we did in the past unit. So this vanishes, this goes to 0, and 0 times sine of x is 0, plus cosine of x times sine of h over h. Now as h goes to 0, sine h over h goes to 1. So I have 1 times cosine of x, which is cosine of x. Hence, the derivative of sine of x is cosine of x.